Herzlich willkommen zur 9. Episode von Elektroautomobil, dem Podcast zur Elektromobilität. Ein frohes neues Jahr wünschen euch Valentin Buss
und Markus Zacher.
Umweltfreundlichkeit von Elektroautos wird ja viel diskutiert. Immer wieder gibt es auch Studien, manche werden pro, manche kontra BEV angeführt. Je nachdem, welche Annahmen für die Studien getroffen wurden, kommen da auch ganz unterschiedliche Dinge raus. Und wir haben uns ja schon öfter damit beschäftigt und auch hinterfragt, wer hat diese Studie jetzt in Auftrag gegeben? Verwundert uns das Ergebnis im Anbetracht des Auftraggebers vielleicht doch nicht so sehr wie beim ersten Angucken? Solche Dinge. Die Tendenz ist gefühlt, dass je aktueller die Studie ist, umso eher fällt sie auch positiv für Elektroautos auf, weil einfach neuere Zahlen oft belegen, dass eben die Produktion von Batterien doch nicht mehr so schmutzig ist, wie man das vor ein paar Jahren vielleicht noch angenommen hatte oder wie es vielleicht wirklich noch war vor einigen Jahren. Genau, und Autohersteller selbst bewerten natürlich auch ihre eigenen Produkte hinsichtlich des Fußabdrucks. Viele haben sich ja jetzt auch auf die Fahnen geschrieben, zum Beispiel CO2-neutral zu werden. Und so müssen sie für ihre eigenen Produkte nicht nur für ganze Autos, sondern auch für Teile der Fahrzeuge bewerten, was für einen Fußabdruck in CO2 zum Beispiel das Ganze ausmacht. Und da gibt es das Instrument des sogenannten Lifecycle Assessments, LCA oder LCA. Und da guckt man sich sozusagen von Anfang bis Ende, von Produktion bis Verschrottung sozusagen an, was mit einem Produkt für zum Beispiel CO2-Ausstoß verbunden wird. Oft wird dann auch CO2-Äquivalent berechnet, also sozusagen nicht nur CO2, sondern wie viel Treibhausgaspotenzial entsprechend Tonnen CO2 bewirkt das Ganze dann.
Genau, und wie Valentin schon gesagt hat, die Autohersteller gucken sich das ja immer intensiver an, weil sie natürlich auch wissen müssen, an welchen Stellhebeln müssen sie arbeiten, um den CO2-Fußabdruck zu verringern. Und eine Automarke, die das auch gemacht hat, ist Polestar. Polestar ist ja bekanntlich eine Tochtermarke von Volvo, die auch wie Volvo aus Schweden kommt. Und die haben das für ihr erstes rein elektrisches Auto, den Polestar 2, auch durchgeführt. Also auch Polestar hat eben auch ein LCA erstellt und diese Studie auch veröffentlicht. Und wir haben uns natürlich gefragt, wie geht man da eigentlich vor? Wie wird so eine Studie erstellt? Welche Annahmen werden dafür getroffen? Wie geht man da heran? Und wir hatten die Möglichkeit, mit Lisa Bolin zu sprechen. Lisa ist eine der federführenden Experten der Polestar-Studie. Und da Lisa Schwedin ist und wir des Schwedischen nur bedingt mächtig sind, haben wir das Interview auf Englisch geführt. Und das geht jetzt direkt los. Viel Spaß beim Anhören.
Hi, Lisa. Great to get to know you. Would you like to introduce yourself?
Yes. So my name is Lisa Bolin, and I am working at Polestar at the headquarters in Gothenburg, Sweden. And I am, my position is called Climate Lead, which means I am working a lot with climate and sustainability as a whole as well. And I have been focusing a lot on life cycle assessment for the last year. And we published a carbon footprint of our Polestar 2. So that has been taking up a lot of my time.
So you started, what was the motivation to start with this LCA?
I think the motivation is several different parts, but first of all, we see that our customers ask for this type of information, so we want to be able to provide it, as well as it's a great tool for us to use to be able to see the hotspots, you can say, on where emission takes place in our value chains, for example. I'm not sure if the audience is familiar with life cycle assessment, so maybe I should say
I was
something
about
to
ask to clarify what is a life cycle assessment and what it is not.
So as you can hear from the name, life cycle and assessment. So it's basically an assessment where you look at the whole life cycle of a product or a service. Well, it all started with the realization that if you just look at your own operations as a company, for example, for us, we might do changes in our operations that will make, well, the environmental impact lower for us, but those changes might change something that will increase emissions somewhere else in the value chain or after we have sold the car. So yeah, that's why it's important to look at the whole life of the car, from all the materials coming up from the ground, all the refining of materials, production of the car, the use of the car, and also the scrapping and what happens to the materials at the end of the car's life, you can say. Yeah.
So maybe to summarize, or like I understood it, it's you actually check for the especially on the CO2 emissions for the complete production of a car, including materials, sourcing of the materials, the usage of the car, and finally recycling or whatever happens to the car afterwards.
That's right. Yeah.
And you focused on a special car, although on one certain car of Polestar, I guess.
Yeah. So that's actually important thing to remember, that our carbon footprint is only for our car Polestar 2. And I mean, that's not representative for any other electric vehicles out there. So that's a good point. And we did this project together with Volvo Cars. So and the good thing about that is that we then were able to compare to petrol car from them, so that we can, in that way, we can control that the same methodology for the calculations were used for the petrol car and our Polestar 2. Yeah.
So which was the petrol car you've chosen to compare the Polestar 2 with?
That was a XC40 with the petrol engine.
Okay. So actually, soon this car will also be available as a BEV version. So will the results also be valid for the BEV version of the XC40?
Not really, I would say.
Not really. Okay.
They are. I think that maybe many people are aware that they are coming from the same platform. But I mean, the Polestar 2 and the XC40 differs a lot when it comes to. Well, you can see the difference basically. So in terms of the top hat and the energy use, maybe when you drive it, they have a little bit different aerodynamics and so on. So I wouldn't say that you can just, it's not exactly the same.
Oh, okay.
A question from my side would be, as I understood, there are no clear standards in an LCA where to start and where to end the life cycle assessment. So like the system barriers or so in your case, where did you start and where did you end?
That's a good point. When we started this project, we of course started to look at what have other OEMs done, what have suppliers done, when trying to get a hold of the situation. And a lot of companies, a lot of car manufacturers do present life cycle assessments or the results of that life cycle assessment or carbon footprints, but we were not able to really understand, at least not from most of the OEMs, how they actually calculated it, and also the methodology was not really presented, which it makes it becomes a problem, because in life cycle assessment you do a lot of assumptions, and those assumptions can affect the results quite a lot. So that's actually one of the reasons why we wanted to present our full methodology, both in order to be very transparent towards customers and other stakeholders, but also to kind of push for more transparency when it comes to life cycle assessment and methodology. And I mean, in the long run, it would be good to set down some basic standards and, on how we calculate in the life cycle assessment of vehicles. I know there are work going on in different places on that, but we really want to start that dialogue as well. And, now it's more like presenting figures, but it's hard to understand how are those figures calculated. And to your question, we follow the ISO standard for life cycle assessment. So we do a so-called cradle to grave life cycle assessment, which means that we start from the earth crust, you can say, like from the mine or the oil well or the whether you take up the natural gas or whatever it is, until the actual scrapping of the car. So that's all included. Yeah.
Is also included, especially for the battery, which I think if you have a look at the numbers, I think the battery will be one of the main parts in the carbon footprint and production. Is that also including second life and recycling afterwards?
We have actually assumed recycling for our batteries. That doesn't mean that that's what's going to happen. It's very hard for us to do those assumptions since it's far into the future, and a lot is happening with batteries and so on. So, but so we didn't include second life, for example. Yeah.
So probably it could even be better with second life, because then probably the battery will be used, I don't know, 6 or 8 or 10 years longer than only in the car. Probably, we don't know yet.
Yeah, this is a discussion. In real world, yes. In general, if you use products for a long time, they can replace new production. So that's good. But when you calculate in the calculation, it can be a discussion sometime. Who is going to take responsibility for the burden of producing the battery? Is it us, or is it us and the next user, and so on? So, but in the real world, of course, it would be great. Yeah.
But in your case, you took the whole responsibility as a first user for the production.
Yes.
And when you say recycling, you calculated the recycling cost or the recycling footprint after the use, but you the battery itself in the footprint, the production of the battery is not from recycled material, but from virgin material, right?
Yes. I think it's important to point out that in this type of life cycle assessment of vehicles in general, and that's also the case for Polestar, we use a lot of generic data. So I don't want to give the impression that we have followed every value chain down to the mine and collected all the data from all suppliers or throughout the whole value chain. That's not the case. In the battery case, though, we have carried out the LCA together with our suppliers. So they have given us all the data about their production and so on. And also some data coming from their suppliers. But those value chains are very long. So that's going to be a work we have to, continue to get more and more specific data. Yeah.
And can you summarize some main assumptions you've made? So, for example, for the mileage of the car, or the time it will be used, or that how long will last the battery? Is there a battery swap plan? So maybe after, 160,000 kilometers, you say the battery needs to be renewed, or will it last longer? And you assume that also?
So we made the assumption in this study that for 200,000 kilometers of driving, and there's a lot of different assumptions made in different studies of different car brands, everything from 150,000 up to 300,000, and I don't think that number should be confused with how many kilometers you can actually drive the car. That depends on a lot of things, but we have not calculated for any swap of battery. So we have actually just one battery in that calculation for 200,000 kilometers. But you are right that the guarantee, I think, is 160,000 kilometers. But that doesn't mean that the battery is not used working after that.
That will be worse. So if after 8 years, maybe all the batteries will be broken, then you've made something wrong.
But that's leading back to that battery question before. That I mean, all our cars are new, and well, we have to follow this to see what can happen to batteries after they have been in our cars and so on. So that's yeah.
Okay. So maybe two potentials I've recognized so far are actually that probably the battery will last longer than 200,000 kilometers, maybe 250,000 or whatever, or the whole car. But we don't know yet, of course, because cars are really new currently. And the other hand, maybe there's a chance in 10 years or in 8 years to have a second life, but this is not planned so far yet or not calculated. And actually we don't know yet how the second life, what will be possible in 8 years, maybe. So
of course, we are exploring a lot of different options for our batteries, but we have not included it in the life cycle assessment. Yeah.
Okay, but I think that's very fair, because now, so you have assumptions where you have had a look on the life of the car where you really know, or you can make very good assumptions, or what will happen, and not something which is too fuzzy maybe.
No speculations, but more hard facts.
Yeah, that's the thing, that in this carbon footprint we have made quite conservative assumptions sometimes like this. I mean, but at the same time, we don't want to make assumptions that will give the impression that we are trying to make it look better than it might be. And also the actual, I mean, the result of the LCA or the carbon footprint is one thing, but what we really wanted to have as a result as a company is to know where do we really need to focus our efforts. And I mean, batteries, for example, is a given one, but we also understand that, aluminium, steel, maybe electronics are also parts where we have to put in a lot of effort. Yeah.
So the LCA shows you where are the biggest levers to change the carbon footprint. So we talked about battery. What else are very important levers?
So aluminium, for example, is a material with a very high carbon footprint in many cases. I mean, due to a lot of electricity use in the value chain. But also, I mean, it has a high potential of becoming much better if you can switch to green electricity and so on. So I think that's one thing that we are working hard on to see whatever we can do there. I mean, so there's, of course, there are different roads you can take here, and we try to pursue several of them. I mean, working with suppliers and supply chains to see what we can do there to minimize the emissions, but also, I mean, sometimes it might be a question for our engineers. How can we replace materials or do it differently and so on to for example, do we have to have aluminium there? Can we have steel? Or is it, can we have more recycled? I mean, there are a lot of recycled material, steel and aluminium. So it's also important to understand where can we use that and what parts of the car can we not use that due to maybe safety or other things. Yeah.
Which parts of the Polestar 2 are in aluminium, or which are the main parts where we used aluminium for?
Well, for example, there is a lot of aluminium in the casing of the battery pack. Yeah, that's an example.
Okay. Body and white?
Not really.
Okay, so it's mainly steel, probably.
Yeah. I mean, I hope I'm not lying now, but no, but there are, I mean, a lot of aluminium in the battery pack, for example, and so on. So that's a good point too. Like, we have to look, where do we have big parts of aluminium that we can focus on? I mean, there's of course aluminium in many, many components of the car, but might be small amounts. Yeah.
Okay. And maybe what will be really interesting actually are the results of your LCA. So what everybody always wants to know is, okay, if I buy an electric vehicle, is that good for the planet or not? So do I have finally more emissions? So this is also what many studies which were published in Germany assume that, or so the old so-called Sweden study from I think 2015 or something, where the electric vehicle was calculated pretty bad. So, but the update, which was published, I think this year, it was much better because also the production of batteries and the cells and so on were improved a lot. So
is that an IVL study, right?
Yeah, I think so, yes. So in Germany, we just say the Sweden study and everybody knows which is...
Okay. Yeah. So I think that I think that we have to look at the broader picture when it comes to electric cars. And so I would say that, yes, I obviously think that electrification is the future. And we have to look at, as a whole system, is electrification a good idea or not? And I think that that's clear that it is. And there are studies on a more macro level that looks at, okay, if we change a lot of the fleet to electric cars all over the world, what's the difference and so on? That's one thing that I don't want to use our study to prove that electric cars are good or bad, or, that's not the point of our study. But I also want to say that in our study, the Polestar 2 comes out better than the XC40, call it the petrol car. And even we did 3 scenarios. So one scenario where you charge with a global average electricity, and then one for the EU average electricity, and then one with wind power. Because, what you charge the car with obviously has a great impact on the total carbon footprint. And they all came out better. But of course, the global charging with global average electricity, then the Polestar is closer to the XC40. But I think that the important thing is that to also compare what are the prospects for those technologies. We have the potential to make, if when we look at charging with renewables, then the use phase basically becomes zero. There's some emissions related to producing windmills and so on, but they're neglectable, I would say, in this case. Then, that's why we try to work so hard now on our material supply chain and everything, because that's where we need to work. But for the petrol car or diesel car, there's actually no. They can come down to very low emissions from their materials and production, but the emissions in the use phase will always be there. They can't really do anything about that. So I think they also have to think in a longer perspective, where we see that electricity will be decarbonized in many parts. We see that already, that it's really going down, like in the EU, but that's what has to happen all over the world. So then, so it is that's also a conservative assumption in a way, to say that you drive this car maybe, let's say 10, 15 years, I don't know. And we assumed that the global average was the same, like the global average electricity is the same during that whole period, which is very unlikely. And even more unlikely in the EU, I would say. So the emissions from the use phase for a specific vehicle will probably get better and better. So
you calculated actually, for example, for the European electricity mix with the current electricity mix for the next, 8 years? Or did you also calculate it including a electricity mix which will be getting greener in the next years? Or you took the status quo? So if we don't do anything in the next years, it will be this value. But if we will have more wind power, more water power and so on, then actually it will be even lower.
Yeah, exactly. So that's why it's quite conservative.
Okay. But also with these conservative numbers, also for the usage maybe, actually the Polestar 2 is better in the life cycle emissions in any case, or in of these 3 cases you have calculated, than the petrol engine powered XC40.
Yeah.
Yeah. So maybe I will just read the numbers here for our listeners. So the XC40 is calculated with 58 tons of CO2 equivalent. The Polestar 2 with a global electricity mix is 50 tons, so it saves 8 tons over the life cycle. Then calculated with the European electricity mix of today, then it's 42 tons. So you save 16 tons of CO2, and powered with electricity from wind power, then it's 27 tons. So less than half of the petrol engine. So you can save like 50% or more than 50%. Yeah. I think what maybe is important to know, I think that the global electricity mix has a lot of, I think, coal, also energy from coal, I guess.
Yes, a lot.
Yeah. So probably
I don't remember the exact percentage. I'm sorry, but yeah.
Yeah. So probably, I think there are a lot of coal power plants in China, and also, of course, in Europe, or also in the US or India. So if this becomes better, then also this way, of course, will getting lower. Yeah. But I think important for us here actually is the European electricity mix. And so there's also a potential to reduce this, of course, if this is getting better. And I think this must be the goal if the European states will follow the goals of Paris for 2030 and 2050 and so on.
Yeah, and I mean that's what we see our role as well to be. I mean, we kind of assume that not only us will produce we produce a product that fits into that future, and we expect also that the emissions from electricity will go down because we see all those goals, and also in some places legislation taxing on CO2 and so on. So
So what's actually the mix you have in Sweden? Do you have a lot of wind power, water, or also nuclear energy?
We have well, roughly then, because I don't have the numbers here. I think we have about 50% hydro, maybe, or is it 50? Yeah, let's say it's like 50% hydro or 45% nuclear, or maybe it's the other way around, but it's mainly nuclear and hydro.
Okay.
Then we have some fossil electricity from local. We use district heating in Sweden, so some of those produce a little bit of electricity that comes from natural gas, and then also we have some imports during some time of the year from probably Germany. Yeah. So, but I mean, we have a very low, I think around 50 grams of CO2 equivalents per kilowatt hour, something like that.
Really low. Yeah.
So it does make a lot of sense in Sweden to drive electric.
Sweden and Norway.
Standpoint. But then again, there's of course more atomic waste than in other countries, so that's enough salt.
Yes.
Okay, maybe do we have some final questions?
Yeah. So what is actually? So are you looking in for Polestar? So finally, what's your final goal with the LCA? You want to achieve probably in 10 years or in 20 years, or what is? Would you say where we've started with that, and what's your final goal actually in the long term?
As our final goal must be to become climate neutral. I think we can't really aim for something else. Looking at where we are in the world with the climate crisis and so on. So, but steps on the way is to. I mean, we are not going to make that in a very for the next car. I mean, so we have to make sure that for every car that we make, we have to be able to make sure that we implement new. It can be new technology, it can be new ideas in design, it can be new materials. We have to prioritize those big materials and go down the value chains to be sure that we can choose suppliers that have lower carbon emissions and so on. So there's a lot of things to do. But I mean, the goal of the LCA is to really make it clear where we have to put in the effort, and then we just have to start to do it. Yeah, and it's not easy, but yeah, it gives us a prioritization, a way of prioritize as well. Yeah.
So it's also a goal to have just more transparency over where are the big levers in the footprint, and also maybe get some more transparency also in the comparison to other cars from other manufacturers, maybe by showing how you are doing it, how you are calculating it.
Yeah, and that's also a thing. Like we would really like to. Our goal with the transparency is both to make it easy for people like yourself or our customers that are. We have a group of customers, I think, that are very interested in those questions, and we want to. If you want to know more, you should be able to know how we calculate it and so on. But also push for that in the industry. We can get more transparency in general on what are the actual environmental impacts from the cars that we sell, and not only electric vehicles, of course. I mean, there's a lot of pressure and there's a lot of questioning around are electric vehicles really good or bad? But I mean, I think that the conventional combustion engine vehicles, they should also have this pressure to show their carbon footprints and so on.
It's a question which was never asked before. So only with the BEVs, this question was asked. And I think it's pretty good that we do this. But like you said, it's a question we have to ask for any product, actually. And your results show that the BEV is better in your case for the climate. Of course, it's not zero. Yeah, this is also something I think everybody needs to learn, that every product which is produced had a footprint or an impact. But this must be as low as possible. And maybe one last question. So what is your target year of Polestar to become completely carbon neutral?
Yeah. Internally, we are quite sure about when that is, but unfortunately, I can't reveal that now. I can just say that, I mean, we are working very closely with Volvo, and they have said they're going to be climate neutral in the whole supply chain 2040. Okay. So I mean, we can't do worse than them. We have to at least reach that. So that's just a hint, I guess.
Okay. Thank you.
Yeah.
So my last question would be, now that this LCA is out, can you maybe tell us something about the next thing you're working on, or is it top secret?
No, I can. I mean, we have said that we're going to make these types of carbon footprints for the cars that we, all the models that we release, or the cars that we release. So, I mean, we are working on that, obviously, for our future products. And but important thing is to know that this carbon footprint was made when the car was already ready for manufacturing, basically. We knew everything about it. We knew what parts is going to be in the car, the materials, and so on. But a big part of my job is also to work in the development of cars, to assess, should we use this material, that material? Can we, to assess those types of questions with the help of life cycle assessment. So it's not just to evaluate a product that we already made, but to try to, as early as possible, give feedback on, maybe try to use that polymer instead of that one, or can we use some other materials, or and also pushing our suppliers to work with us on this type of assessments. Yeah. So
not only talking about it and publishing something you have written, but also really working on reducing the footprint. Yeah.
I mean, that's that's the actually most important thing, I think. And that's also something that we kind of commit to now, even if we haven't said we're going to reach this low figure of CO2 for our next car or anything like that. But I mean, people will assume that we are trying to lower this number, of course. Mm-hmm. So, I mean, we have to work very hard with that. Yeah.
Great. Okay. So, yes, thank you very much for all these super interesting insights of this calculation. I think this should be done for any car, actually. And it's really cool that you shared these results. So we will put some of the diagrams also in our show notes. So for the listeners, so that they can check out the numbers we've just talked about. And again, thank you very, very much for coming to our show and discussing a very important topic, I think.
Mm-hmm. Thank you so much. It has been very fun to talk to you.
It's been a great pleasure.
Yes.
Thank you. And
thank you.
Bye.
Goodbye.
Goodbye.